Okay, we had discussed about the syllabus, and we had seen what are the various components of a transmission system. Okay, it has a clutch, gearbox, propeller, differential gear, etc. So it is mainly helpful in transferring the power from engine to the rear wheel. Okay. The propeller shaft transmits the final torque to the rear axle. Rear axle has a differential gear which will equally divide the power to both the wheels. Okay. So it has certain functions. It has to disconnect the engine from driving wheels whenever required. Okay. The engine should be connected back whenever required without any jerking. Okay. The torque ratio should be changed. This will be done by the gearbox. Okay. The first two functions will be done by the clutch. The third will be done by the gearbox. And fourth, it turns the drive through a right angle. This will be done by the differential gear mechanism. So all of this we will be discussing in detail in the upcoming topics. Okay. So the important components we had discussed yesterday: clutch, gearbox, propeller shaft, universal joint, and rear axle. See here, as I discussed the first two functions, that is connecting and disconnecting the engine from the transmission system, and without jerking, that function has to be done. That will be done by the clutch. Okay. Changing the gear ratios and proportions as per the requirement will be done by the gearbox. Okay. Transferring the power from gearbox to the rear axle or differential, that will be done by universal joints and propeller shaft. And finally the power has to be divided equally and shifted at right angles. Okay. That will be done by the rear axle as well as the differential. So these are the different components of a transmission system. So first we will start with the clutch. Okay, yesterday we had discussed the functions of clutch. Okay, and when the disengagement should actually take place. Okay, and what are the design requirements of a clutch we had discussed. One is torque transmission, gradual engagement, heat dissipation, dynamic balancing, vibration damping, clutch size, and easy in operation and lightness. These points we had discussed yesterday. Then also we had discussed about the different types of clutches: friction clutches, fluid flywheel clutches. Okay. In friction clutches, the transmission of power is caused due to friction between the two rotating members. Okay. And in fluid flywheel clutches, energy transfer between two members take place because of movement of fluid. Okay. Okay. We were stopped at this point, that is principle of operation of clutches. So how a clutch works. So you can see the two important components here. The clutch operation is based on the frictional contact between the two members. You can see this is the first member. Yeah. So this is the first member. Yeah. The end A will be connected to the flywheel. Okay. Flywheel, which is in turn connected to the engine output. Via flywheel, end A will be connected. Okay. So here, this is actually the friction plate, the second friction plate. So the other end of the friction plate will be connected to the gearbox. Okay, gearbox. Okay, here engaging and disengaging takes place at this point. Whenever you want to keep the vehicle in idle or start the vehicle, this will be disengaged. Okay. Once it is started, when you apply the load, these two will come in contact. Whenever you want to shift the gear, you will press the clutch pedal so that these two get separated. You can change the gear ratio. Then whenever you release the clutch, both of them engage together. Okay. So this is the principle of operation of a clutch. Okay. The clutch is a friction type coupling which will transmit the power from one shaft to the other shaft. The shaft axis should be the same. Okay. So this is done by bringing both driving and driven members. Which is the driving member here? The engine end is the driving member. Okay. And the transmission end or gearbox end is the driven member. Okay. So the clutch in gradual contact. So gradually they have to come in contact with each other so that there will be no jerk. Okay. Slippage occurs during clutch engagement. There are certain mechanisms to avoid the slip also. Okay. So the main criteria is the RPM of the engine shaft and the RPM of this should be almost same, so that whatever slippage produces, okay, or whatever easy or smooth jerkless will be there. Okay. So the clutch material should be considered such that during the design, so whenever they try to come in contact, there will be some amount of friction. Because of friction, heating will be there. So that heat should be absorbed by these two plates, B and D, and gradually it has to be dissipated to the atmosphere. These are some of the requirements and the working principle. Okay. Just with the help of a video, I will show you different parts of a clutch. So that first is the engine side. You can see in the sketch clearly that red color, whatever arrows are rotating, that is the engine side. Just you'll get an idea what are the different parts and how it works. The other end is the gearbox side. Okay, you can see the different parts. So whatever you can see, this is the flywheel. In module 1 we have discussed the functions and all. This is the clutch plate. Okay, whenever this clutch plate comes in contact with the flywheel, okay, the clutch is said to be engaged. Whenever it moves away from the flywheel, it is said to be disengaged. Now see, both are in contact with each other. In between, you can see a circular ring with springs, which will keep a tight contact so that there will be no slippage. I was talking about slip. And this is the cover. Okay, you can see there is a diaphragm inside, a net-like structure present inside. So this diaphragm helps in keeping a firm support. You can in the upcoming part they will show how diaphragm works also. See, whenever you plus the clutch, what is happening? You can see the diaphragm moves inwards, whereas the clutch plate will move outward. You can clearly see in that video. Okay, whenever there is a contact, you can see the engine shaft as well as the gearbox shaft both will be rotating. Okay, this is the diaphragm. You can see the arrow there. This is the diaphragm. Okay, you can see how the diaphragm, when the clutch is pressed, the diaphragm will move inward. Okay, the clutch plate will move outward. So this will give you an idea of how a clutch works and what is the principle of operation of clutches. Okay. So next we'll go ahead with different types of clutches. Okay, friction clutches. We are discussing about friction clutches. So that is the first type. So there are six different types: dog clutches, cone clutch, single plate clutch, multi plate clutch, semi centrifugal, and centrifugal clutch. So one by one we will discuss in detail now. First we'll start with the dog clutch. Please make a note of the sketch. Okay, I think we'll move ahead. Okay, a dog clutch couples two rotating shafts, okay, or other rotating components not by friction but due to interface. Okay, it is like a gear mechanism. Okay. So earlier in the principle, whatever we saw, principle of operation of clutch, the two clutches were held together because of frictional force. Okay, but here it will not be a frictional force. There will be a gear-like teeth mechanism and a sleeve. With the help of that gear-like mechanism, it will be attached. That is why it is called as a dog clutch. Okay, you can see the first shaft, a engine shaft side, wherein a dog clutch teeth is there, external teeth will be there. In the shaft B, okay, there will be internal teeth. In the next animation, I will show you how the internal teeth will be. In between, there will be a connecting sleeve. Okay. So here the friction is not an acting member. Here the main acting member is the direct contact between the two gears. Okay. The two parts of the clutch are designed such that one will push the other. Okay. So there will be a tight force. Force acts from both the ends, from shaft A end and shaft B end. So there will be a tight contact without any friction. The rotation takes place. Okay. Where slip is totally undesirable. See, wherever friction is there, with aging, small amount of slip starts in clutches. You need to replace the clutch. Okay, wherever the slip is totally undesirable, we can opt for dog clutches. Okay, there will be no question of any slipping because here it is not because of the frictional contact. Totally there will be a external and internal teeth based gear mechanism. Once it clubs together, okay, there will be no question of slip expected. Okay. Dog clutches are used in manual automotive transmissions. A semi automatic transmission mechanisms, usually this type of mechanism is used. Okay. A synchronous arrangement ensures smooth engagement. Okay. So this is the application of a dog clutch. Okay. You can see a small animation here just to give you an idea. Okay, this is a totally different type of clutch which doesn't work on the principle of friction. There is a sleeve like mechanism. Okay, it will be in between the two shafts. See, one is shaft end A and other is the shaft end B. Okay, whenever they meet together, you can see that sleeve helps in proper joining. There will be no question of any colliding. So it helps in properly aligning them. Whenever you disengage the clutch, they move apart. Okay, this will be a ring-like structure in between. Whenever you engage the clutch, there will be a uh, tightly they get attached to each other. There will be no question of any slipping. If you ask why, because there is no space for any movement. So there will be no question of any slipping. So this is the first type of clutch. Coming to the second type, cone clutch. Please make a note of the sketch. I'll give you just 2 minutes time. The principle of operation is same. Okay, so two plates will meet and help in transferring the power. But here, it again the attach. I mean, the both the plates attached only because of friction. In the first case, it was because of a gearing arrangement. Hence, it is called as dog teeth. Okay. The second is because of the friction between the two elements. This is the friction surface you can see. I'll give you 2 minutes time. Please make a note of the sketch. Please make it fast. Okay. So you can see this is the engine end. So this is the engine end and this is the gearbox end. Okay. In a cone clutch, the friction surfaces are made in the form of a cone. The name cone clutch is given because, see, in the video you were just observing, we saw a circular disc like friction material. That is a circular disc like structure. There is a flat clutch. Okay, here you can see instead of circular disc, it is made in the form of a cone. When they assemble, okay, they assemble in the form of a cone. You can see this is the driving end, engine end, and this is the driven end, gearbox end. Okay, so the gearbox end is connected with the help of a spline shaft so that there will be no question of slipping. Okay, this is the engine end. Okay, in a cone clutch, the friction surfaces are made in the form of cone. Okay, when the clutch is engaged, one cone will sit completely inside the other cone. That is the driving cone sits inside the driven cone clearly. Okay, the from the engine flywheel, so here somewhere the flywheel will be there. Okay, the torque is transmitted to the splined shaft. Okay, so in turn it will be connected to the gearbox here. Okay, the spring, here you can see there is it is a spring loaded arrangement which will keep in tight contact between them. In the dog teeth clutch we saw there was no question of any spring because it is a gear like arrangement which will avoid the slipping. Okay, here if there is no other force acting in the opposite direction, both of them may not be kept in contact all the time. Okay, in order to avoid that slipping, there is a spring, okay, which will always keep in contact these two friction, cone A and cone B, in tight contact. Okay, what is the advantage of this mechanism? The cone clutch can transfer a higher amount of torque, okay, compared to other clutches of same capacity. If you ask why, because of the wedging effect which avoids the slipping, and also because of the increased surface area of contact and higher friction, it can transfer more torque compared to other type of clutches of same size. Okay, so they are usually confined to very special transmission in racing cars, okay, in extreme off-road vehicles, etc., in power boats, etc. These are some of the applications in racing cars, rallying cars, off-road driving vehicles. Okay, if you ask why, okay, it doesn't require complete disengagement and engagement. Even the partial, okay, disengagement will also help in shifting the gears. So gear shifting will be very much quicker. Okay, when you want to move the vehicle at a very high rate, okay, gear shifting lag will be very much less in case of cone clutch. Okay, so these are the applications and working. See, working principle almost it will be same, only the construction part will be different. This whatever this portion is there in different clutch will be different. Ultimately both the plates has to meet and transfer the power from the engine shaft to the transmission, I mean gearbox shaft. Okay, so this is about the second type, that is the cone clutch. Okay,